So currently, if you have potential melanoma, what you'll do is you'll go to the doctor and they will look at your skin mole and examine it, and through visual interpretations, they'll try to figure out if you have potential to have cancer in that mole. And so what they'll then do is send you to the dermatologist, who will then examine it themselves, and if they feel that you have melanoma, they will then excise the potential tumor, get a biopsy of it, and then send that to the pathologist, who then has to analyze it just by looking at the cells visually, using a couple other techniques, and they'll decide if you have cancer. And so what we kind of want to do is have a more novel approach, a non-invasive screening method to detect it at an earlier stage and to help give you a reason to get a biopsy so you don't need to get one unless we absolutely are sure that you have melanoma. What we can kind of do is take mass spectrometry and use a couple different ionization methods and then analyze the mole directly and try to develop, again, a screening for melanoma. The first step is identifying biomarkers, and so to do that, we need to use a technique called metabolomics. And so what we kind of do is take all of these features that we're analyzing with mass specs, so like the mass of the compound, the retention time in the chromatography column, the combination of the two together, and we put all these features into a statistical analysis called principal component analysis. And so you can put in thousands of features, and you're bringing that down into a couple principal components. And then those can separate things based off of how they load in what's called a loading spot. And so if you get a separation of melanoma versus normal cells, then you can look back at those masses and try to establish potential biomarkers for melanoma. Within the next 5 years, I think it will be kind of establishing these biomarkers and identifying them and making sure that they are actually kind of involved in the pathway for melanoma. When you get these masses, there's sometimes dozens of compounds that can have that exact same mass. And so the problem is then, as a chemist, I'm obviously not the best at determining what is pertinent into like a pathway of melanoma, so then we'd get a biologist or pathologist to help us out and kind of say, yes, that's probably important to the metabolic pathway. And so not only does that give us a biomarker for melanoma, but that could potentially help us figure out more about the pathway itself. Because right now, we know what happens once you have melanoma, but it's really unclear how the process begins. So this is kind of twofold in that you get a diagnostic test for non-invasive screening, and you get to hopefully help yourself out in more developing the pathway as we know it. The Orbitrap is definitely very helpful, especially with the accurate mass capabilities, and that's probably the most important aspect of mass spec research in terms of identifying biomarkers, because you can't really identify anything if you don't have the elemental composition of it, and that's what accurate mass gives you, is the ability to take an unknown mixture, put it through the mass spec, and you get out exact masses to the fourth, fifth decimal place. I also use an ion trap, which is still useful in its own right for targeted analysis, but when you're doing global metabolomics like what we're doing, trying to identify a couple things out of a pool of thousands, nominal mass just doesn't cut it, because you're given, it says a mass 152. Well, there's thousands of compounds that have a mass around 152, and so the Orbitrap is incredibly helpful in that respect. If you do want to learn more about the melanoma research that we're doing, we have a website for the Southeast Center for Integrated Metabolomics, and we do a lot more than just melanoma too, so if you are interested in metabolomics in general, or if you want to learn more about the melanoma project, you can go to that website at the University of Florida